Hello, so today we're going to be looking at another lead code problem. This is problem number 560, and the problem is finding subarrays of sum equal to k. And what this problem expects is that we return the count of subarrays that sum up to value of k. Now, this problem is a little bit similar to another lead code problem 209, where we had a similar setting. We were given integer array nums, and we were given a target variable k, and we have to do something with respect to getting the subarrays with respect to the target variable k. Now, at a very high level, the two problems are similar in settings but very different in methodology, and that's because the previous problem had all positive integers, and because they had all positive integers, we were able to leverage that structure and implement rolling window concept, where we kept dynamically increasing a subarray size and shrinking the subarray size. And what that meant was, every time a subarray sum was lesser than the target value, we increased the subarray and subarray on the right hand side and included more elements from the right hand side till the whole subarray sum reached a particular target or overshoot the target value. Then in that case, we started dropping the elements from the left of the subarray and shrinking the subarray. Now, all of this was possible because these were positive integers, which meant including another number would increase the sum of the subarray, and dropping a number would reduce the sum of the subarray. But this is not quite so when you have negative numbers. So let's take a quick example and look at it, right? So let's say I have a nums array that looks something like this, and let's say that I'm supposed to reach or find a subarray which gets me a target of sum equal to 0. As you can see, there is a subarray that can give me a target sum of 0. But if we go by the rolling window approach, what we get is we're going to keep accumulating the values, right? So I get -1 here, I get -2 here, and I get -1 here, which meant that the current running sum was still lesser than target, and the expectation is to keep expanding because, as per the algorithm of the rolling window, I still haven't reached the target value, so I have to keep expanding. But that's not the case here, right? So this is one of the reasons. And another possible case when you might think of not using these rolling windows is when it's not just the positive and the negatives of it, but it's not very clear in terms of how to, or rather when to expand and when to shrink, when the direction is not very clear in terms of the operation, then rolling window is probably not a good choice. And as you can see, it's in case of negative integers, it's also not going to give us the right answer. So for this problem, we're going to be looking at a different approach. We're going to be looking at something called as a prefix sum. So the concept of the prefix sum is that if this is my subarray of sum equal to target, and this is another subarray which is of value prefix, and this is something that I have computed as I was traversing through this array, then I can say that prefix plus my target value is equal to my current running sum. Okay, and now this becomes an equation for me, because I can say that if current sum minus target is something that I have seen before is a question mark, then I can say that yes, this is possible, or I can say that no, this is not possible. Alright, so that is the approach that we're going to take here. Now let's quickly code this up in Python. So I'm going to use a prefix dictionary to capture the scene as a concept. I'm also going to do one more thing, which is capture the counts because um, we are dealing with negative, positives and negatives, so there can be multiple combinations that can give me a specific prefix. For example, I can have a 0 here and I can have 1 and minus 1. So this before the target, let's say this is the target subset. So this is one subset, this is another subset, that, and then this in itself is also another subset, right? So these are all the subsets that can give me the sum of target. So let's have the prefix value here and let's have a count here. Now another thing that I'm doing here is I am initializing the prefix. So this is the prefix sum and this is the occurrence count. Okay, and what this default value means is that if a target happens here where it starts from the starting of the array, this particular subarray is not going to have any prefix. So we're going to say that by default, if the sum, the current running sum at this point minus the target is going to give me the 0 value, then I need to account for that and I need to account for that default state and say that there is one state, one possibility of getting 0 prefix, which is if the target subarray or if the potential subarray starts from the first or the 0th index. So we're starting with this prefix and we're going to say that current sum, which is my running variable, is equal to 0. I'm also going to maintain another variable called counter, and this is because the problem expects me to return the count. If it was a boolean problem or some other thing, then I would have handled it differently. Because I need the count here, I'm going to keep this counter variable. Now next we're going to start with another pointer. So next we're going to go through each of this element and keep building the current sum, and keep building the prefix sum value, and to do the computation. So let's see that. Okay, so for lm in nums, first thing is add it to the current running sum. So current, so for me it is cur sum, so cur sum plus equals to lm. Now what I'm going to check is this condition. The condition is count, which is the current sum minus the target is equal to certain prefix, and I want to check if this prefix has been seen before or not, if this prefix has been seen before in this or not. So let me do that. So if current sum minus k in prefix, then I will have to increment the counter, but I'm going to increment the counter by the number of occurrences of that prefix, because that prefix could have been seen multiple number of times. So counter plus equals to prefix of this difference, which is current sum minus k. Alright, and the next thing would be to take the current sum itself as another prefix for further subarrays. Okay, so, and there is a possibility that this prefix could have been previously seen, so let us try to fetch that. So we say prefix count is equals to prefix dot get of current sum, and if this was not seen before, let's add a 0 as a default value. And so now we set it that current sum as a prefix was seen prefix count. If it was seen earlier, then take that value and add 1 to it, otherwise it's going to be 0 plus 1, and then finally you return the counter. So this is the algorithm. If you code this up, this will work for you. Hope this made sense, and you can code it up in any favorite language of your choice. Alright, that's it from me. Thank you. Bye bye.